All right, welcome back, boys. So we are still reviewing. So we are still in chapter 3, which is talking about functions, but we're going to learn about what it means to be a linear function. Okay, and we're going to do that by using graphs, tables, etc. Okay, so let's begin. Again, a lot of this is a review from previous months. So we have some vocabulary. So a linear equation in two variables is when it can be written in the form of y equals mx plus b. So we're gonna later this week, I'm gonna reteach you what it means to be y equals mx plus b, okay? And don't forget, that is slope-intercept form, all right? So the graph of a linear equation is a straight line, and that means it's a linear function. All right, so we're all about straight lines. So some more vocab. A linear function has a constant rate of change. Okay, and that's going to also be referred to as slope, which is going to be the next review lesson tomorrow. Now, a non-linear function does not have this constant rate of change, so therefore, it is not a line. Okay, so it would be a curved line. Okay, so now you're going to see some graphs. So you need to identify, does the graph represent a linear or non-linear function? So if you look at letter A, well, it has a curve in it and it's a parabola. So it's non-linear because it's not a line. Looking at letter B, well, that obviously is a straight line. So it is linear because it's a line. Letter C has a curve, obviously. So it's non-linear because it is not a line. And then letter D, obviously it is linear because it is a line. Now, those were easy. Now, the next thing I'm going to show you is a table, okay? So, does the table represent a linear or non-linear function? So, if you remember this, what you had to do was find for me the increase and decrease. So, if you look at this, whoops, to go from 3, excuse me, I don't want that. To go from 3 to 6, you added 3. From 6 to 9, you added 3. And from 9 to 12, you added 3. Oh, that's a good sign because they're all the same. The bottom, if you go from 36 to 30, you minus 6. From 30 to 24, you minus 6. From 24 to 18, you minus 6. So, if you remember, you had to write me some words. So, as x increases by 3, y decreases by 6, so it is linear. So this was the sentence that you wrote me, okay? So as long as the numbers on the top are all the same, numbers on the bottom are all the same, then it is linear, okay? And increases obviously means it was added, decreases obviously means it was subtracted. So let's look at letter B. So from 1 to 3, we added 2. From 3 to 4, we added 2. From 5 to 7, we added 2. All right, good so far. Now let's look at the bottom. From 2 to 9, you add 7. From 9 to 20, you're adding 11. From 20 to 35, you're adding 15. Oh no, not a good sign. So as x increases by 2, y increases by different amounts, so it is non-linear. So because those numbers on the bottom are not all the same, that is why it is non-linear. Okay, we have 2 more. So letter C, from 2 to 4, add 2. Whoops. From 4 to 6, add 2. 6 to 8, add 2. Good so far. The bottom, looks like we add 9. Add 9. Ooh, add 9. All right, we have a good thing. As x increases by 2, y increases by 9, so it is linear because it has that constant rate of change. All right, last one. From 1 to 3, add 2. 3 to 5, add 2. 2 to 7, add 2. All right, good so far. All right, 1 to 27, add 26. From 27 to 125, you are adding 98. And then from 125 to 343, you are adding 218. So obviously it's not going to be linear. So as x increases by 2, y increases by different amounts. So it is non-linear. Okay, so I believe in Big Ideas you actually have to use a drop-down menu for like the missing word, so make sure you pay attention to what I'm writing. So yeah, your assignment's on Big Ideas, and I will see you guys next time. Take care.